rice-based farming systems predominates the land use system in Limbutichu watershed. It highlights the importance of access and management of irrigation water to sustain the rice production. The watershed is drained by the 11-kilometer long rain-fed stream Limbutichu that originates as a spring from a rock face at an altitude of 2,400 meters north of Limbukha village. The 6 villages share irrigation water within a broadly respected customary regime that evolved during times when water demand was lower. Limbukha village, situated at the uppermost catchment, have absolute control over irrigation water, which deprives other villages for assured irrigation. From recent past, Limbukha introduced potato as a promising cash crop in the rice-based system, which is expected to influence water sharing system. The conflict on water sharing between two villages, Limbukha and Dompola, in the upstream has existed for a long period. As the time passed by, two villages diverged more from collective management and has reached to the point of no compromise. The fundamental question can be if there is a way to bring these two villages together to create shared learning and identify workable strategy. Secondary data and diagnostic study of the area helped in conceptualization of the study. Water sharing systems at different levels were critically analyzed, networking and exchange protocols. General understanding of the socioeconomic aspects of the study area and decision-making process helped in conception of role-playing game to authenticate the understanding of the context generated from reviews and field study. The role-play game was meant also to put the farmers in a situation created based on what they narrated and what researchers perceived. Thereby, it would help in further generating unique behaviors and interaction protocols. Two simple game boards, one for Limbukha and the other for Dompola, drawn on a poster paper representing the farmers in columns and their plots in rows. On the game board, columns represented 6 farmers and rows represent plots that ranged from 1 to 8 depending on the category of the farmer. Each plot is equivalent to 0.1 hectare of paddy field and only one crop can be grown at a time. Different playing cards were used, for instance cash, several denominations, rainfall, normal and low, crop, potato and rice, water, market state. Rainfall patterns drawn randomly were declared before the game started. Market state price was declared after each game. 2 sessions of role-playing game were played in May and December 2003. Limbukha farmers planted potato and rice, while Dompola farmers planted only rice based on their resources. The rules of the game is explained to the players. The rainfall pattern is declared. Players are given water cards. Limbukha farmers plant potato. Farmers from both villages plant rice. In the second step, Limbukha farmers harvest potato and plant rice. Dompola farmers also plant rice. Both the villages harvest rice and farmers are paid their income. In the role-playing game, three modes of communications and exchange were played in each sessions. Number one, within each village. Number two, between villages. And the third one was swapped roles. Multi-agent simulations was used to model the role-playing game to expand the exploratory capacity of the study, which could not be done in role-playing game for its design complications and high demand for resource and time of players. 36 scenarios were generated using 3 social networks, 6 exchange protocols, and 2 rainfall patterns. From the lessons learned from the study, role-playing game is an efficient approach to bring two conflicting communities to discuss the issue through game. Role-playing game is a self-motivating and non-threatening approach which facilitates free and productive interactions among players. It helped in enhancing the knowledge of players on sharing and managing resources more efficiently. From the lessons learned, if we compare the responses in May and December sessions, we see the shift of perception from individual lessons towards shared vision of water management. Role-play game also showed how players make decisions. While some behaviors are very mechanistic, some use their intuitions to make decisions. There are some who try to copy the example of the best players. Communication modes and exchange of protocols was the key factors which influenced water use. Multi-agent system simulation is an efficient way to generate multiple scenarios using communication modes and exchange protocols. From the simulations, it was revealed that exchange protocols influenced the land use decision and income, while decisions were independent to kinship network. These findings will be presented to the farmers to explore with them which kind of exchange protocol would be adapted and the ways of institutionalizing them.